Good day, everyone. This is Group 1 discussion about similar solids. Objectives. At the end of this discussion, you will be able to define and identify what is similar solids, find and use the scale factor of similar solids, determine the surface area and volumes of the similar solids, apply the similar solids in the real-life problems.
First, I would like to define the definition of similar solid. Similar solid are two solids that has the same shape and all the corresponding dimensions are proportional. As we can see here, we have these two similar solids which is similar cones that I have drawn for the example. So, two solids with equal ratio of corresponding linear measure such as height and radius are called similar solids. And the common ratio of two similar solids are also known as the scale factor of one solid to the other solid.
Here are some examples of similar solids. Letter A. Decide whether the two solids are similar. If so, compare the surface areas and volumes of the solids. Solutions. Letter A. The solids are not similar because the ratios of the corresponding linear measures are not equal, as shown. 3/6 is equals to 1/2, which is the length. 2/4 is equals to 1/2, which is the width. 2/2 is equals to 1/1, which is the height.
Solution. The solids are similar because the ratios of corresponding linear measures are equal. As shown, 3/6 is equal to 1/2, which is the length, 2/4 is equal to 1/2, which is the width, and 2/4 is equal to 1/2, which is the height. Moreover, the surface area and volume of the solid are as follows: prism, surface area, and volume. Prism is equal to 1/2, and surface area is equal to 1/2 squared, which is 1/4, and volume is equal to 1/2 cubed, which is 1/8. Therefore, the ratio of the side lengths is 1:2, the ratio of the surface area is 1:4, and the ratio of the volume is 1:8.
Theorem. Similar solids. If two similar solids have a scale factor of A and B, the corresponding areas have a ratio of A squared and B squared, and the corresponding volumes have a ratio of A cubed and B cubed. The term areas in the theorem can refer to any pair of corresponding areas in the similar solid, such as lateral areas, base areas, and surface areas.
Example number 2. Using the scale factor of similar solids. The prism is similar with a scale factor of 1:3. Find the surface area and the volume of prism G given that the surface area of prism F is 24 square feet and the volume of prism F is 7 cubic feet.
For the solution, begin using by 1:3 to set up the two proportions. The surface area of F over surface area of G is equals to A squared over B squared. 24 over surface area of G is equals to 1 squared over 3 squared, which is 1/9. Now, we cross multiply it. 24 times 9 is equals to 216. Now, therefore, the surface area of prism G is equals to 216 square feet. For the volume, volume of F over volume of G is equals to A cubed over B cubed. 7 over volume of G is equals to 1 cubed over 3 cubed, which is 1/27. Now, we cross multiply it. 7 times 27 is equals to 189. Therefore, the volume of prism G is equals to 189 cubic feet.
Check your work. You can check your work by substituting back into original proportion. Surface area of F over surface area of G is equal to A squared over B squared. 24 over 216 or 1 over 9. For the volume. Volume of F over volume of G is equal to A cubed over B cubed. 7 over 189 or 1 over 27. Therefore, for the surface of area of prism G is 216 square feet, and for the volume is 189 cube feet.
Example number 3. Finding the scale factor of similar solids. To find the scale factor of two cubes, find the ratio of the two volumes. A cubed versus B cubed is equal to 512 over 1728. Write the ratio of volumes. A over B is equal to 8 over 12. Use calculator to take the cube root. Then simplify 8 over 12 or 2 over 3. Therefore, the two cubes have a scale factor of 2 over 3.
Example number 4. Using volumes of similar solids. The lift power of a weather of a balloon is the amount of weight the balloon can lift. Find the missing measures in the table given that the ratio of lift powers is equal to the ratio of the volumes of the balloon. Solution. Diameter, volume. 8 feet blank feet cube. 16 feet blank feet cube. Find the volume of the smaller balloon whose radius is 4 feet. Volume is equal to 4 over 3 pi 4 cube. Volume is equal to 4 over 3 times 64 pi. Volume is equal to 256 over 3 pi. Volume is equal to 85.3 pi cube feet.
Example number 4. Using volumes of similar solids. The scale factor of the two balloons is 8 over 16, or 1 is to 2. So, the ratio of the two balloons is 1 cube is to 2 cube, or 1 is to 8. To find the volume of the larger balloon, multiply the volume of the smaller balloon by 8. Diameters, 8 feet and 16 feet. Volume, 85.3 pi feet cube and 682.4 pi feet cube. Solution of the larger balloon. Volume is equals to 8 times 85.3 pi. Volume is equals to 682.4 pi feet cube.
Example number 5. Comparing similar solids. Swimming pools. Two swimming pools are similar with a scale factor of 3 by 4. The amount of chlorine mixture is needed is proportional to the volume of the pool. If 2 cups of chlorine mixture is needed for the smaller pool, how much of the chlorine mixture is needed for the larger pool? Solution. Using the scale factor of the volume of the smaller pool to the volume of the larger pool is as follows. A cube is over B cube is equals to 3 cube over 4 cube, which is 27 over 64 or 1 over 2.4.
The ratio of the volume of the mixture is 1 semicolon 2.4. The amount of chlorine mixtures by the larger pool can be found by multiplying the amount of chlorine mixture for the smaller pool by 2.4 as follows. 2 times 2.4 is equal to 4.8. Therefore, the larger pool needs 4.8 cups of chlorine mixture.
Summary. Similar solids are two solids has the same shape and their corresponding dimensions are proportional. The ratio of corresponding sides of similar solids are equal. And symbol small h over capital H is equal to small x over capital X and small y over capital Y. The common ratio is called the scale factor of one solid to the other solid.
The areas which are base, lateral area or surface area of similar solids have the same ratio as the squares of any pair of corresponding sides. In symbol, small a over capital A is equal to small h squared over capital H squared, where small a and capital A are the corresponding areas and small h and capital H are the corresponding sides. The volumes of similar solids have the same ratios as the cube of any pair of corresponding sides. In symbol, small v over capital V is equal to small h cube over capital H cube, where small v and capital V are the corresponding volumes and small h and capital H are the corresponding sides.
To determine if solids are similar, set up a proportion of corresponding dimension. Similar solids have exactly the same shape but not the same size. Two solids are similar if the ratio of the corresponding linear measurements are equal.
So, what are linear measurements? Linear measurements are anything that are still in that one category. So remember, when we say P, A, V, or 1, 2, 3, these would be things like height, width, length, any radii or radius, diameter, slant height, perimeter, and even circumference. Those are all considered linear measurements. In order for us to determine if solids are similar, we're going to have set it up an extended ratio, kinda like what we're doing to similarity check. So, 8 with 2, 20 with 5, 12 with 3. I'm just gonna set it up. This is the old, and this is the new. So, we're gonna do 2 over 8 is equals to maybe, 5 over 20 is equals to maybe, and 3 over 12 is equals to maybe. If you go ahead and simplify them right away, just it will make your life easy. So 2 over 8 does become 1 over 4, 5 over 20 does become 1 over 4, and 3 over 12 does become 1 over 4. And because all of these have the same ratio, then you can say yes, they are similar, and your scale factor is equals to 1 over 4 or 1:4. This one right here, we're going to have 10 over 6 is maybe equal to 10 over 6 is maybe equal to, and 12 over 8. And let's go ahead and simplify. Divide by both by 2, so we have 5 over 3 is equals to 5 over 3 is equals to 3 over 2. And no, this is not similar solid. Number 3, do the same thing, but I want to point out that this one has given you the diameter and this one has given you the radius. So when you're setting up the ratio, you can either do the diameter to diameter, so 20 over 24. Since this entire diameter would d equals to 20, or you can do radius to radius and do half of the right there, 10 over 12. No matter what's gonna give you that same simplified ratio. And yes, they are similar. The scale factor is equals to 5 over 6 or 5:6.
Comparing volumes and surface area. If two solids are similar with a scale factor of A to B, then their volumes and surface areas are as follows. Surface area. Use the original scale factor A to B. Volumes A to B. Remember the PAV 1, 2, 3, 1, 2, and 3. So you have to use the original scale factor no matter what you have. Always level power down and power up to what you need. Always come back to your scale factor no matter what you've given, and then you can find the volumes and surface area. So I'm gonna do the number 4 with you. It doesn't matter what kind of solids you're working with, as long as it is told that they are similar, then it's totally fine. This is the old and this is the new, left and right. So I'm gonna use the altitude of both of these, 3/6, but I don't have to use 5/10 or 7/14. All of them I don't have to, but if you want to use one of those, then it's totally fine. Now 3/6 goes ahead and simplifies 1/2. So it means the scale factor is 1/2. Again, you can also use and you can also write it as 1, 2, 2. Alright? Now, you have to do the PAV 1, 2, 3. So we're going to square this. So we got 1, 2, 2 here. And we can also have 1/2. We're going to square the entire thing. So all of these square. In other words, you're gonna do 1 squared over 2 squared equals 1/4. Next, you're gonna find the volume. So you're gonna use power of 3. 1 cubed over 2 cubed. 1 times 1 times 1 is equals to 1. 2 times 2 times 2 is equals to 8. So the answer is 1/8.